Hi all, this lecture will be on Introduction to Hypothesis, in which we will focus on the z-test in this lecture. This lesson may be one of the most important ones out of the course, so please ask questions right away if there is any misunderstanding when going through this video. So let's start off with a potential question we may want to answer. Suppose we have a random sample of 50 pizza deliveries of a company that claims to deliver under 30 minutes on average. If the sample has a mean of 28 minutes, and suppose we know the population standard deviation is 5.6 minutes, can we determine that the population mean delivery time is less than 30 minutes? This is the type of question that we will answer using hypothesis testing. Basically, we can conclude that the mean is less than some number, greater than some number, differs from some number, or we cannot, and later we will get into proportions as well. But this one's just the mean. In every hypothesis test, there are two hypotheses. The first one is called the null hypothesis. It's null, as in nothing, or in other words, no information. It also is known as H naught. So again, the null hypothesis is the hypothesis of no information. And the second hypothesis is the alternative hypothesis, and it's labeled as HA or H1. The alternative hypothesis is what we are trying to prove, and we are assuming the null hypothesis unless we have sufficient evidence to conclude that the alternative hypothesis is true. So we want to prove the alternative hypothesis. That's very important. So let's talk about the concept of hypothesis testing. So it's actually modeled after the criminal justice philosophy that the defendant is innocent until proven guilty. So for this scenario, the null hypothesis, what we are assuming, which is that the person is innocent, versus what we are seeking to prove, and that the person is guilty. So innocent is H naught, until proven guilty is HA or H1. Continuing with the analogy, we have two possible conclusions. If the defendant is found guilty, then we say reject H naught. There is sufficient evidence to conclude what HA said. That's the defendant is guilty in this case. Otherwise, if the defendant is found innocent, that does not mean necessarily that the person is innocent. It just means that they don't have enough evidence to conclude that the person is guilty. So in that case, we would say fail to reject H naught. There is not sufficient evidence to conclude that the defendant is guilty. And I want to emphasize that because that's very different than saying accept H naught. There is sufficient evidence to conclude that the defendant is not guilty. That is different. If we are failing to reject H naught, then that really means the results are inconclusive. So we don't affirm the null hypothesis. So we're not accepting the null hypothesis. So that's the concept, and there are 4 steps to hypothesis testing, and I'll walk you through each one, but let's just go over which one, the 4. The first one, we set up the hypothesis, so we set up the H naught and the alternative hypothesis. Step 2, we have to calculate the test statistic and the p-value. Step 3, we have to state the rejection rule, and the last step, we state the conclusion in the words of the problem, which it is important to put the conclusion in terms of the scenario. Don't just repeat every single problem the same conclusion. Put it in terms of the scenario. In the criminal justice example, step 1 was H naught, innocent. HA, the alternative hypothesis, was proven guilty. The test statistic and p-value are essentially the evidence. The rejection rule would be to prove beyond a reasonable doubt, and jury would have to determine that. And the verdict is the conclusion. So in more detail, the first step, setting up the hypothesis. The first test we will do is the z-test, which is analogous to the z confidence interval that we just went over. We will be testing about the mu, so the population mean. So we have three possible sets of hypotheses. The null hypothesis is always mu equals a specific value, and the alternative would be that the population mean is less than some value or greater than some value, or it might just be not equal to some value. So these are the three alternatives, and see that this is always the same. Some textbooks may say that the null hypothesis would be the opposite of the alternative hypothesis, which would be the opposite to less than, which is greater than or equal to, or opposite of greater than, which is less than or equal to, etc. Which is okay, but usually we just write it as equals versus less than, greater than, or not equal to. So when you're doing it from the homework and the test, write it, always do the null hypothesis this. And it doesn't affect anything really, since we never conclude H naught, so it won't affect it, but I like to see this. And mu naught is the hypothesis value, so you wouldn't write mu naught, you would write the value. If it is less than or greater than, it's called a one-tailed test. Less than is a lower-tailed test, while greater than is an upper-tailed test, or a right-tailed test. And then not equals is a two-tailed test. So again, the alternative hypothesis is what we are trying to prove. So usually the first thing we will do is read the problem, and whatever the researcher is trying to prove, we put as the alternative hypothesis. So in this one, the researcher believes the mean is greater than 50. So that means the alternative hypothesis is mu is greater than 50, and the null hypothesis will always be that same number. So that means H naught, or the null hypothesis, is mu equals 50. So let's do some examples. In this first one, we have an economist who wants to know if the average price has decreased for a 20-inch flat screen TV since 2002, when it was $530. So think about what the hypothesis should be, pause the video for a minute, and then check the solutions on the next slide. So here's the answer. We want to know if the average price decreased, which means less than when it was $530. So the alternative hypothesis is mu is less than 530. And the null hypothesis is mu equals 530. Here's another example. A farmer is trying to decide whether to use the same brand of tomato plants next year, and we want to know, do they produce more than 20 per season on average? So pause the video again and try to write the hypothesis down. Okay, in that one we are looking to prove whether mu is greater than 20, so the null hypothesis is mu equals 20, and the alternative is mu is greater than 20. And another one, a criminologist is interested in whether the average sentence for repeat drunk drivers has changed since 1990, when it was 90 days. So try that example real fast. Okay, for this example, the words has it changed means it could be less than or it could be greater than. So that means it will be not equal to. So the alternative is mu is not equal to 90, and the null hypothesis is mu is equal to 90. So let's recall the pizza delivery example from slide 2, I believe. What would be the hypothesis? They claimed they delivered in less than 30 minutes on average. So that means the alternative hypothesis mu is less than 30, and that means the null hypothesis is mu equals 30. So I hope you guys are getting how to set up the hypothesis. But moving on to the next step, which is calculating the test statistic and the p-value. The test statistic is calculated based on the data. Every hypothesis test has one, and the different hypothesis tests have different formulas to calculate the test statistic. So here's the z-test that we're focusing on. It is x bar, which is the sample mean, minus the hypothesis value divided by sigma over the square root of the sample size. And just to be clear, I'll use the notation z star, and your textbooks uses z, which is okay, but I just want to use z star in z-test just to clarify. So this also may look familiar. If you recall the central limit theorem slides, this actually comes from the central limit theorem. So for our pizza delivery example, if we plug in the mean, which is 28, minus the hypothesis value, which is 30, over, we said that sigma is 5.6, and divided by our sample size, square root of our sample size, which is 50. And putting that in your calculator, we get negative 2.53. So that's our test statistic here. Again, notice the standard deviation is from the population, so that's why we use the z-test and not the t-test, which we'll do the t-test next. So this again is the z statistic. So now we need to calculate the p-value. So what we want to do is find how likely it is to get a sample mean as extreme as the one we got if we assume that the population mean is as hypothesized. So we need to find the probability, assuming mu equals 30, that the mean of a sample of 50 will be less than or equal to 28. That's the p-value, and that comes from the central limit theorem. So we want the area below negative 2.53. So we are finding the probability by looking up negative 2.53 on the standard normal table, like we always do, and we get 0.0057, and that's the p-value. In this case, that is the probability of getting x bar, or sample mean, less than or equal to 28 if mu equals 30. Does the probability of 0.0057 indicate that the probability is unlikely? Well, that brings us to the rejection rule. That's step 3. The researchers decide on a cutoff point before running the test, which is called your alpha, or your level of significance. 0.05 is the most common level of significance, and that comes from the rare event rule. The other common levels are 0.1 and 0.01. If there is ever a time in the level of significance or alpha is not given, just assume 0.05. So when it's not given, just say alpha equals 0.05. Probabilities that are unlikely will always be below that level of significance. So the rejection rule is reject H0 if p-value is less than alpha, or regardless of whether the alternative hypothesis is less than, greater than, or equal, not equal to. It is always reject H0 if p-value is less than alpha. Again, always reject H0 if p-value is less than alpha. Remember this. That's why I made this slide. It's very important. It's always less than alpha, the p-value. So stay tuned for the next video. I'll pick up right here with step 4.